Today is day 5 of our manufacturing week, where we talk about the future of manufacturing. Now, before going into the latest and greatest into the manufacturing industry, Sandeep, we made a promise to the audience on day 1 that we'll have an interesting guest today, a student developer who has done some really amazing work with us. So what do you have for us in store?
Absolutely. I think it's been one hell of a journey for us this week. And I think there could not have been a better opportunity for us to end this slot with a guest. And we have Advait, who is joining us from Mumbai.
Yeah.
And he is a student developer, 11th grader. We collaborated with Advait a few weeks back. In fact, he interned at the tech center, a short summer assignment.
Yeah.
Day 1, we kind of showcased Hydroponics.
Yeah.
Right? Now, it's been an aspiration for a long time to build some growth models on that. See, one is, of course, we've done descriptive all these days. To understand what's happening in real time in terms of ORP value, pH value, luminosity, and all the stuff, right? So we understand that. But can we use data that we get from that and build some predictive models? And Advait, thankfully, has done the brilliant job in kind of building machine learning models using a service manager. I would love for him to talk us through that, but that's what we have today, Rishabh.
Okay. Sandeep, for the audience, before actually handing over to Advait and learning about what model he has built, can we actually go ahead and have a view of what the hydroponic setup looks like?
Absolutely. Let's do a recap of what we kind of showcased earlier this week.
Yeah.
So as you see here, this is basically a hydroponic setup, Rishabh. Now, we've seen this day in and day out, right? Now, hydroponic, for the large audience, it's an urban farming technique. You grow plants with just pure water, right? Of course, nutrients, solvents added into the water for the growth. And typically in the modern world where land is scarce in the urban city, and it's still grown inside. And to see these being housed in a multi-stored environment, dominantly used in the Middle East, where again there's a dearth of, I would say, fertile land, right? Yeah. So this setup has multiple sensors baked in, Rishabh. There's a Raspberry Pi that's there to scan into multiple sensors, be it ORP, pH value in water, or luminosity that we kind of have it. We also have a camera here, which kind of, at any point in time, if you want to understand, you want to take a picture of this plant every day once, right? So what we've done is, basically, we've taken pictures of the growth of these plants through a 30-day period. And we gave that to Advait, right?
Yeah.
And that's when the magic happened. And let's welcome Advait.
Yes.
And see what he has to tell us about this. Advait, are you there?
Hi, can you hear me? I'm great. Thanks for having me here.
Quick question to you. We collaborated a few months back to actually build a growth model on this hydroponic. How did you approach this, right? I mean, we told you were interested in tech for sure, but the problem was in front of you. How did you go about building machine learning models to actually understand how these plants are growing? Just take us through the approach. Then I'll have a few follow-up questions to you. Yeah, so over to you.
Right. So the task at hand was to basically, given the image of the hydroponic setup right there, basically to find out which lettuces were healthy and diseased and kind of score them up whether they were healthy or not. So the approach I took initially was to basically have a model that I built through Microsoft Azure Custom Vision Service that you suggested actually initially, right? And that would basically identify all the lettuces first in that in the given image, and then it would crop into all the lettuces that it identified and create, maybe if there were 6 lettuces it identified, creates 6, and then it would send each of these images into another model that was also built through custom vision that then classified them as healthy or diseased and gave a score saying how sure it was about the prediction it had made.
Wonderful. That was great, Advait. Quickly, right? So I recall a point in time where you trained the model on plants which you typically downloaded from internet, right? The images of plants. Now, the reality check was the actual images I gave you, right, from a tech center, and model didn't do that well, right? And that's when you said, can you send me these images? See, end of the day, this is a lesson for all of us, right? The model has not been trained using the real images that was meant to be classified end of the day. And hence the accuracy was low. Then we started giving you images on a daily basis. as an indication of growth of these, when you retrained your model, right? So take us through that journey and just show us what accuracy you get today in terms of identifying the good, classifying them, and also you put a bounding box around to identify where, which row, which part is the plant being grown. You can identify that, right? So just take us through that process as well.
So this is the image right from the hydroponic setup. I think about a week. This image came about a week ago.
Right.
So basically the model will, as I said, it will draw bounding boxes around each lettuce and that it detects, and depending it will either classify them as, if it's healthy, it will be green, as you can see here, or it will be red. So it's, if it was diseased. So it's classified all the lettuces here as healthy, and it's even labeled them in rows and columns. So this is the first row, then the second row, and the third row.
Wonderful. Now, that's great, Advait. Thank you so much. In fact, this is a proof of the pudding. And honestly, the magic was done by custom vision dominantly. It's such a simple technique that we adopted. At the end of the day, it is a true power of Azure Cognitive custom vision that came in handy. I think you did a lot of programming as a pre-processing, right? Just to ensure that the images are right. And also, putting bounding boxes on the image was your logic. Also, your logic was to also identify which row, which plant. That was also a tricky thing. One of the questions that I had for Advait during that assignment was, hey, help us identify good versus bad. Not in terms of how it looks, in terms of the green intensity,
Yes.
and also hygiene factor, right? Imagine the use case in the agri-tech right now, agriculture right now is, I go to the shop, but basis my preferences, which one should I pick up?
Yeah.
Advait, one last question to you. I know you did have some logic behind giving the score. I think you gave a health score to each of the plant. Just explain that part.
Sure. So I did some research. I had no idea, but darker green lettuces tend to have more vitamin K and I think some minerals as well. So they're actually better and healthier. So what the model does is it tries and identifies all green pixels, and then it charts out their intensity, where the brightest lettuces have a low score, and the darkest lettuces, since usually they tend to have the highest nutritional content, have a higher score. So this doesn't really indicate whether they're healthy or diseased, just an approximation of what nutrients you might get on a relative scale.
Awesome. I think, you know what, thanks so much, Advait. Truly appreciate your time this evening. I know you just rushed from school for this one. Truly appreciate your time this evening, and good luck to you, Advait.
Thank you very much for having me. Really appreciate it.
Awesome. So,